Welcome to another unit of the ISM Exercise Set Statistics 2. This time with a unit on probability theory. Let's take a look at the exercise. A university offers 3 study programs: National Management, NM, Regional Brand Management, RBM, and Physiology and Management, PM. The respective student shares are 43, 27, and 30%. 34% of the NM students complete more than 2 internships. With RBM students it's 41 and with PM students 6%. Then we have 3 tasks. First, calculate the probability that a student completes more than 2 internships. Part B, you meet a student that only completed 2 internships. What is the probability that he studies RBM? And C, 4,000 students are enrolled at the university. How many of these study PM or NM? So let's start with the first one. Here what we are interested in is the probability that someone performs more than 2 internships. Let's call this here P of 2i. What we have from the exercise text is first off the probability that someone studies NM, which is 43%, and under the condition that he studies NM, the chance that he has more than 2 internships is 34%. So here, this second part can be written as a conditional probability. Similarly, the numbers for RBM and for PM. Well, what we are actually want to calculate here is in the end nothing else than the weighted average of the 3 conditional probabilities, whereas the probabilities of studying in one specific study program, so the probabilities on the left, give us the weights. So if we take a closer look at the weights, we see here, first off, they make up 1 or 100%, and they are disjunct, so there's no one there who studies more than one study program. Also, everyone studies at least one of the study programs. So with this in mind, we know we can apply the so-called theorem of the total probability, which in the end is nothing else than the weighted average of the conditional probabilities. Applied to this case here, would look as follows. So it's always probability of being part of one group times the conditional probability. And we do this for all 3 parts and add them up. So if we just insert our numbers from above, we get this here, and put into the calculator, this gives us 27.49%. That's the probability that in general someone performs more than 2 internships. This concludes part 1 of this exercise. In part 2, we are interested in, again, a conditional probability, but here under the condition that someone has not done more than 2 internships. What's the probability that he studies RBM? So here we have a bit of a small haggle because, well, we are only working up to this point with probabilities of more than 2 internships. Now it's not more than 2 internships, so it's a complement. So when we consider what we have been given, we need to do some small recalculations as well. In particular, first off, okay, we know probability that someone studies RBM is 27%. That's still okay. Then we need the probability that someone does not have more than 2 internships. Well, we know the probability that someone has more than 2 internships, so we can just go 100% minus this probability, which we calculate just in part A. Then we get the probability that someone has 2 or less internships, being 72.51%. Similarly, we only have the probability that if someone studies RBM, there's a chance of 41% of him having done more than 2 internships. However, if we want to turn this around, we want to know of him not having done more than 2 internships, we just go again by 100% minus 41%, giving us here a probability of 95% that if someone studies RBM, he has not done more than 2 internships. And that's everything we need to actually then apply the so-called theorem of Bayes. We can imagine this here as we start with the last conditional probability, and what we want to do is switch the 2 parts of the conditional probability. So before it was the complement of 2i under the condition RBM, and now we want to have RBM under the condition complement of 2i. So just moving this around, and this is always an indicator that we need to use the theorem of Bayes. Here, the formula for this would look as follows, and we see we have all the 3 values we need for this. So the first one, that's the conditional probability of 59% times probability of someone studying RBM of 27% divided by the probability of someone having 2 or less internships, which we calculated above with given parts, of 72.51%. If we enter this into our calculators, they give us as a result 21.97%. So if I meet someone who has done 2 or less internships, there's a chance of 21.97 that he studies RBM. And this is then the answer for part B. In part C, the final part, we're interested in first off the probability that someone studies PM or NM, and we want to know not only the probability but how many of the 4,000 students actually fulfill this. So we need the probability times the 4,000 students. So what we know here, probability of studying PM is 30%, probability of studying NM is 43%, and well, implicitly, as there's nothing else in the exercise, we assume that everyone studies just one study program, which also makes sense for most of the students. So probability of someone studying PM and NM at the same time is 0. Then we can just use the formula for the probability of unions, which is here P of PM and NM. This is just the probability of PM plus the probability of NM. So here we just have to calculate 0.3 plus 0.43, giving us general probability of 73%. So 73% of all our students study either PM or NM. Then we just need to multiply this 73% with the 4,000 students, giving us here 2,920 students who study either PM or NM. And that's then the answer for our exercise part C. Well, having concluded C, we already concluded the whole exercise. And I hope you enjoyed listening to it, you learned something from it. And if you're interested in seeing more of these types of exercises, feel free to visit the rest of the exercise set or take a look at the corresponding playlist. I say goodbye and see you next time.